The unit circle is an important tool when using degrees and radians in trigonometry. Today I'm going to go over what the unit circle is and some examples of how to use the unit circle. Unit circle means that the radius of the circle is 1, and this is a way to label all the degrees, useful degrees, and their common radian counterparts on this circle. So this is the x-axis and this is the y-axis. This is the center. This is 0 degrees, 0 radians. If this is the origin and this is a point on the circle, the coordinates for this are 1, 0. So it's 1 unit to the right on the x-axis and none on the y. The first angle on the unit circle is the 30-degree angle, which translates to pi over 6 radians. And as this is a 30, 60, 90 triangle, the coordinates for this are radical 3 over 2, 1/2, meaning that on the x-axis it's radical 3 over 2 to the right, and on the y-axis it's 1/2 up. The next angle is 45 degrees from here to here. 45 degrees, which is pi over 4 radians. The coordinates for this are radical 2 over 2, radical 2 over 2. Then it's 60 degrees. Translates to pi over 3 radians. And the coordinates are 1/2 radical 3 over 2. 90 degrees translates to pi over 2 radians, and the coordinates for this are 0, 1. Next is 120 degrees, which is 2 pi over 3 radians. The coordinates are the exact same coordinates as this, except the x coordinate is negative. So negative 1/2 radical 3 over 2. Next angle is 135 degrees, which is 3 pi over 4 radians. The coordinates are the same as the coordinates for this, but with the negative x-axis. So negative radical 2 over 2, positive radical 2 over 2. After that is 150 degrees, which is 5 pi over 6 radians. The coordinates are negative radical 3 over 2, 1/2. The next angle is 180 degrees, translates to pi radians, and the coordinates for this on the unit circle for this point are negative 1, 0. On to the third quadrant, we have 210 degrees, which is 7 pi over 6 radians, with coordinates negative radical 3 over 2, negative radical or negative 1/2. So you can see that these are the same coordinates as the coordinates for the angle right across it, except both the coordinates are negative because this is in the third quadrant. Then we have 225 degrees is 5 pi over 4 radians. The coordinates are negative radical 2 over 2, negative radical 2 over 2. Then we have 240 degrees as 4 pi over 3. Coordinates are negative 1/2, negative radical 3 over 2. Our next angle is 270 degrees, which is 3 pi over 2 radians. The coordinates for this point are 0, negative 1. Then we have this angle is 300 degrees. 5 pi over 3 radians. Coordinates are 1/2, negative radical 3 over 2. The same coordinates as the angle right across from it in this quadrant, and the corresponding angle in this quadrant, but just the signs on the coordinates are different. Then we have 315 degrees, 7 pi over 4 radians. The coordinates are radical 2 over 2, negative radical 2 over 2. Then 330 degrees translates to 11 pi over 6 radians. The coordinates are radical 3 over 2 and negative 1/2. And we're back to 360, which is 0 degrees, 0 radians, and the coordinates are 1 and 0. So this is a really helpful tool because we can use this in trigonometry when calculating sines, cosines, and tangents. So we know how an xy coordinate is. These are all xy coordinates. And we can use the xy coordinate, every xy coordinate on this circle, to calculate the sine, cosine, or tangent of any of these angles. And how is that? Xy in the ordered pair translates to cosine theta, sine theta. So wherever you see a question asking for cosine of theta, you know that it's asking for the x-coordinate. And when it's asking for sine of theta, you know it's asking for the y-coordinate. For example, if a question asks, what is cosine of pi over 2? Well, cosine theta is the same as the x-coordinate, and we find pi over 2 on our unit circle. Look at the x-coordinate, and it's 0. Another example, if we're asked for the sine of, let's say, 7 pi over 4, we locate 7 pi over 4 on our unit circle. Sine means the y-coordinate, so we locate the y-coordinate, and our answer is negative radical 2 over 2. And a final answer, or final example, if we're asked to state the cosine of, let's say, 135 degrees. We locate 135 degrees on this circle, look at the x-coordinate, because cosine corresponds with the x-coordinate, and we find that it is negative radical 2 over 2.